I'm a nerd at heart. I've always been passionate about doing something to mitigate climate change, and I'm an inherently curious person. That got me into batteries as a technology and product that is here today. Everyone wants better batteries. The last year and a half has been a very exciting time for the world of electric vehicles. More and more governments and automotive companies have committed to a fully electric future. And there's really one missing link in making that happen, and that's customer adoption has not been as fast as we would all like it to be. And that's really tied to some fundamental issues with the battery and the ability of electric vehicles using today's battery chemistry and technology to meet or exceed the performance expectations customers have for combustion engine vehicles. So you can build an electric vehicle that has long range, you can build an electric vehicle that's low cost up front, but you can't build an electric vehicle that does both. And that's because of the fundamental materials in the battery, their performance cost trade-offs. Now, what we are aiming to do by increasing energy density, this practically translates into range extension, but also offers the automotive companies a lot more design optionality. So our introduction of a safe lithium metal anode with our membrane and a liquid electrolyte allows for the battery to be about 40% smaller and 40% lighter. Sepion's core innovation is a membrane material that stabilizes pure lithium metal anodes during charging. We start first with making our polymer materials through synthetic chemistry. These materials are then characterized and purified and then dissolved into inks where we coat them using a roll-to-roll tool in order to access them in very thin films and enable their facile integration into a lithium-ion battery. We then build our own test cells composed of lithium metal anodes and cathodes, metal oxide materials, where we put our membranes in the center of these cells and our liquid electrolyte. These finished cells are then put into a fixture and cycled using various battery cyclers with different current and voltage ranges to simulate the driving conditions of a typical electric vehicle. At the end of life of these batteries, when they've reached 80% of their original capacity, we then take them down, pull them apart, and look inside to see what worked very well and what didn't, so that we can learn quickly and continue to iterate on our design. This allows for a 40% increase in range by improving the overall energy density of the battery and also a cost reduction. Sepion's really focused on unlocking greater performance for electric vehicles. And what we're looking to disrupt is the entrenched combustion engine vehicle industry. And so, although we're disrupting what they're aiming to do, we are really also trying to adapt and fit with the battery industry, where we can work closely with the existing manufacturing partners so that we can accelerate the pace to market and accelerate the pace of change. My name is Frishmann. I'm the CEO and co-founder at Sepion Technologies.